Good afternoon. Today we're going to talk about normalizing data. My name is Maria Barnes. I am the president of the Access User Group Lunchtime group, and I also run a small business, Barnes Business Solutions Incorporated. I do custom software for small businesses, and I specialize in Access databases and SQL Server databases primarily. I have started working with Power Apps and of course use Access as a common front end. I'm also an Microsoft Access Office Apps and Services MVP specializing in Microsoft Access and have been for 3 years, I believe now. Today's topic is on normalizing data, and the reason that I picked this topic is that I think it's a pretty important foundation for databases, whether it's Microsoft Access, whether it's Dataverse, whatever it is. I've talked to a lot of people, especially those recently, that are trying to get away from databases with code or applications with code. So they're trying to move to Power Apps, for example. Or I've talked to people in the past that have a Microsoft Access database that somebody in their organization wrote. And that person is probably very well versed in whatever specialty that business does or whatever specialty that Microsoft Access database is in use for, whether it be, operations management or manufacturing flow or whatever it is. And tools like Microsoft Access and now Power Apps are designed so that a person can easily pick up what is known to them and make it into a database system and an application that is of use for the company. But what sometimes happens is that if you do not know very much about data and how to store it, the application, while it works, is not maybe optimum. Perhaps it is too slow, or there's data, the same piece of data in multiple places, and those pieces of data get out of sync. And I often get calls from people that have a Microsoft Access database, for example, that started out small and did a great job for the business, and now it's growing and more people are using it, and it's become a bit of a disaster. And one of the common causes for that is not normalizing the data. So I wanted to make sure that this presentation was out there for those that were interested in it, to talk a little bit about how to organize data in a database and how to normalize it. So this is the definition of what normalizing data is: organizing data, creating tables, and establishing relationships between those tables according to rules designed to protect the data and make it more flexible, to eliminate redundancy and inconsistent dependency. So that's the formal rule. What I will typically see is data that looks something like this. So I'll often get, for example, a Microsoft Excel spreadsheet that looks something like this. And, maybe a customer starts out with, in this case, this is an order form that has everything on one page, right? And if we take a look at this, this has a lot of different pieces of data. We've got some customer information over here. We have order information over here. We have order date, delivery type, delivery promise, and then we have details about the order. We even have two sections of that. We have a section for merchandise and a section for service. And then if we can expand down here, we've got a total, and this really belongs, the total really belongs to the order piece. So here we have on one form really 4 different pieces of data, or it could be 3 pieces of data. You could have order details, and the order details could be of merchandise type or service type. Or you could have these two divided into 2 different tables. So that's kind of, a choice of yours. But if I were going to put this into a Microsoft Access database, I would never put all of this information in one table. And if you think about it, the reason is that if you did that and you had, for example, 2 orders for this customer, then you would have information like these pieces in the customer information in 2 different records, one for the first order and one for the second order. And, we would be talking about the same customer. Of course, you probably have an actual order form saved, like a PDF of the order. And if you changed the address on the company or something was updated, you would have that stored on the PDF. But in general, if you were going to update the address of a customer of yours, you would update that in one place, in one record, which was a customer record, as opposed to trying to do it in multiple rows of an order table. Same with things like order items. You can see that this Excel spreadsheet conveniently allows for like 10 maybe places for merchandise items here. And, if you're an Excel spreadsheet, you could go and you could copy and insert rows so that your total stayed updated. But if you're trying to design something like this in a Microsoft Access table, you wouldn't want to have a flat file that said things like item 1, name 1, quantity 1, price 1, net 1, and then item 2, name 2, quantity 2, price 2, net 2, or anything like that, because then you would have to limit yourself to 10 items, for example, and you wouldn't have the flexibility to have an order that had 12 items on it. And that's something that's desirable. So anytime you see things like rows in Excel with the same type of information repeated, that's a clue that those ought to go into a separate table when you're normalizing something. In addition, you might want to have further normalization. For example, there's a mapping here between item and name. And so you probably have a merchandise table someplace that tells you this item number has a name, and that item has also a price that goes with it. So if you were creating this in a table, you would probably want click correctly. No, I don't want sticky keys. You would probably want something like, not the quantity here, but these items, an item name price in something like a price in an item table, merchandise item maybe, or perhaps you have a separate table for service items, or just an items table and there's an indicator that says whether it's a merchandise item or a service item. But then in the actual order table or order details table, you would have perhaps an item number and a quantity, something like that. Or you might want the price because you might want to keep track of what the price was at the time of the order, because the price might change But if the order was in, an earlier date, you wouldn't necessarily want to re-pull that price from a change date. Although sometimes people make a separate price table and they have like a price from X date to Y date is a certain value, and then they record the price changes. So there's lots of different ways to set up your data, but I think the key that I want to talk about today is the fact that you should separate the data as opposed to having it all in one spot. So we might talk a little bit about Access also and how we might put some of these things in Access. So let's pull over another. There we go. So let's talk about the example of the order itself and order details and what that normalization looks like in Access. So we're going to go ahead and set up a table, and on it we're going to have the order ID, which is an auto number, and just we're going to have an order date. We're going to have a delivery type, which is, this is probably comes from a separate drop-down, or maybe we just make it a value list with a couple items in here. We have a delivery promised. Oops. Which is a date, and we have maybe an order total, which is a currency. So this is our order column. Wait a minute. We're going to also add a primary, make that the primary key, and then double check things like the index and whether or not we have this indexed or not. And this is no, so I just don't like too many things to be indexed because you can only use so many indexes over the life of a table. So that's a good practice to get into. So we're going to call this orders. And then we're going to also create the order details. So here we have another ID. And this is the primary key for this table. And we're going to also include, yeah, you're right, Eric. Good point. We probably also want the customer ID on the order itself. So I will include that in just a minute here. Good catch. Okay, so we also want a relation to the order ID here. What? What was that? Okay, never mind. So we might want things here about the item number, and we would have the quantity and the price, and I want maybe item price. I don't like to name things words that are going to possibly be a reserved word. And we have item total or item net, maybe something like that. And that would be our order details. And then we need to talk about how those are related. So we, with the relationships tool in Access, you can put your tables up and then make relationships to them. And so when you're making relationships, you need to think about there's several different types of relationships, but the most common are a one-to-one relationship or a one-to-many relationship. And so in this case, we if we have one order, we're going to have possibly many order details. Now, maybe there's only one detail line in some orders, but we're allowed to have many order details. And in this design, we're allowed to have as many order details as we want. We're not limited, like in the Excel spreadsheet, to 10 of one type and 10 of another type. So to establish that relationship, you simply need to click on and drag and drop one column to the other. And in this case, I very purposely named them the same. So we have an order ID in both tables. And when you do that, it pops up with a edit relationships. And you can enforce referential integrity, which means that if you are doing that and you had data in your table, you couldn't have an order ID of 4 in the order details table and not have that order ID in the orders table. And then you can also cascade update and cascade delete related fields. And that depends a little bit on what you're doing. You typically, in the case of linking them on IDs, wouldn't have any reason to cascade update, but the cascade delete might be something that you might do. And in that case, what a cascade delete would be that if you did have an order ID 4 in your orders table and you deleted that order, then automatically Access would delete all of the detail lines that went with it. And that way you would not end up with what we call orphan records in the order details. You would be enforcing that referential integrity by doing that. So I'm going to create that. And you can see here that we have a 1 on this side and an infinity sign, which indicates many. And then once you do create that join, you can actually edit it and you can see that same information about it. And then you can also click on the join properties and make that join be left or right join by selecting 2 or 3 as the options here. But most of the time we want it to be a join type 1, where we only include the rows where the join fields from both are equal. So that's just a little bit about table setup and normalizing and creating relationships with the tables. And of course, Eric pointed out that this orders table should also have a customer ID in it. And then we would have a customer table with the customer information and a customer ID in it. And then we would create another relationship between the orders table and the customer table. So I'm not going to bother to do that right now, but I wanted to, keep talking about that. And then we would also then have an item table and join the item number with that item table so that you could get a relationship with that as well. So those are the types of things we're talking about. Going back to the PowerPoint, there are several types of levels of normalizing data. And I actually have a link in the last slide here of the presentation to a normalization basics that Microsoft has put out, and it's really pretty good. Let me copy that link for you and put it in the chat. There you go. And it talks a little bit about the description of normalization and why to do it. Things like avoiding redundant data so that you don't waste disk space, so that you don't have maintenance problems where you're trying to update the same piece of data in multiple places. Ideally, the point of normalization is so that each piece of data is only in one place if it has to be updated or if it's updatable. The fact that you have an ID in multiple tables doesn't count in that case because you're not updating an ID. And then it talks a little bit about these forms, first form, second form, and third, all normal forms, and what is part of each form and what we want to do. So the first normal form is when you're eliminating repeating groups in individual tables. And you're also creating a separate table for each set of related data, and you're identifying the set of related data with a primary key. And then it goes through and it gives you examples of setting up a normalized table. And so it talks about here in this example is an unnormalized table. And you often see stuff like that in an Excel spreadsheet, for example. And, you've got an Excel spreadsheet and it's got one worksheet and you've got, so many columns across and so many rows down. And it's very common to, for instance, pick or have the same piece of data in multiple rows. For example, if you were looking at this example here and you were looking at an Excel spreadsheet, student 1022 might be in multiple rows in the spreadsheet. It's also an indicator of something not being normalized when you have like this section here where you have class 1, class 2, class 3. Well, what if the student was in 4 classes? Then you would have a 4th one over here and you'd have to add a new column. It talks about putting things into first normal form and an example in this case of doing that, where we don't want a repeating group like class 1, class 2, class 3. So if you were doing that, just putting things into first normal form, then you would have the student, the advisor, the room, and then the class number. Okay, so each class, we're eliminating class 1, class 2, class 3 by putting each of those in one row. So that's the first step usually, in identifying that you need to not repeat groups here. Then in second normal form, we're going to actually, let me go back up to the examples. We're going to create separate tables for sets of values that apply to multiple records, and we're going to relate those with a foreign key. So in this case, we took the students and we separated out the registration from the students itself, okay? And in this way, we don't have anything repeated, like we don't have these advisor and advisor rooms repeated. The only thing that repeats is the student number and the class number. So in this example, we have a students table that has the student number, which is the key, the primary key, and some other information about the student, who the advisor is and what the room is. And then there's a registration table that has just the student number and the class number. Now, can we get back to the data like it is in this form? Yes, we can. We can create a view to look at across. So that's the second normalized form, to try to separate out into multiple tables when you have repeating information. And then the third normal form is to eliminate data that's not dependent on the key. That's really the only thing in that piece. And in that case, we might pull out the advisor, like Advisor Jones, and assign a room number and maybe even a department number. That's not, the department number wasn't in the original data. But that way, if you had multiple students that have the same advisor, and you were going to change the advisor's room number, then you wouldn't have to do that in multiple student records. You would go to the faculty record. And in this case, the key for the faculty is Jones, which I'm sure you and I both realize that's not a very good key. This is just part of this simplified example to illustrate this. You're separating out any data that's not really dependent on the key student. In other words, the room number was not part of the student's information. It was really part of the faculty person or that student's advisor's information. Sometimes you don't want to go down to the third normal form. So going back to the PowerPoint here, it's not always practical to go all the way to third normal form. If, for example, you only have one piece of data, maybe it's too much of a pain to set up an extra table for that. It really depends, and it's the further down the list and the more normalized you have it, you're less likely to be in a situation where you have to update data in multiple places. But then you do need to worry about if you want to present all the information together, making views to group those pieces of information back together for presentation in something like a report or something like that. If you are going, for example, in Microsoft Access and you are now going to make forms for this. Let's create a form. The order detail, oops, I'm on order details, sorry. Let me go ahead and do the orders first. Yes. Okay, so the order ID is an auto number. So when you start creating it, you will get, and look at this. See how the Microsoft Access did this for you? It even put the details like this. Why is that, do you think? It's because of the relationship that you set up between it, the orders table and the order details. It recognized that and it automatically took did a subroutine or a subform for you with that information in it. So if you were to, sorry, why is this? Maybe because I'm in design view. Okay. There we go. So if you were to take a look, maybe, and I didn't set up a different type, but we're just going to start entering some of the information from our order in here. So I'm going to enter pickup and the delivery promise that wasn't filled in, and some item numbers here. And we don't have an item table yet, but let's just. Oh, let's see. So look at this. The value doesn't match the number data type. So this is a good example of, when you are on a form, you might have the order ID, right? And you might even want to see the order detail ID, or the fact that this is related to this order ID. But if you're going to enter an item in and you're going to have an item ID, you're not going to want to enter that item ID. So you're going to want some type of a lookup so that you can enter the item number in, as opposed to that. And you know what, in this case, the item number probably should have been a character, because that there's nothing wrong with it, a character being a key. But say this was item 203 or something like that. Or if you know, if you're talking about something where you want it to be more readable, you can either make the key be that readable item if it is unique, or you can create some kind of lookup, you know, so that you are not looking necessarily at those totally normalized fields, but at something that's more meaningful for them. I hope that makes sense. The other thing that I want to talk about is just some clues and hints for how to go about doing this. And this is the normalization link that I have. And the other link is something I think that is helpful. It's actually designed for Dataverse, but you can certainly use the same types of ideas for Microsoft Access. So if we take a look at this, and let me put this in chat as well. So depending upon the industry, and there's clickable several different industries: automotive, banking, insurance, healthcare, higher education, K through 12, nonprofit, manufacturing, and media and entertainment. Someone's already gone out there in the common data model to create entities that support typical data schema for specific concepts within these industries. And I think that that might be something that was very useful for, you know, especially if the client that you are either working for or working on behalf of is in one of these industries. It might be something for you to take a look at. For example, if you're looking at the banking industry, maybe, then they have several pre-built entities and workflows that break things down into things like companies, people, prospects, referrals, opportunities, financial products, commercial loans, mortgages, home equity. You can see how they've broken things out. And I just think it's good examples of the types of tables you might want and how you would break them out. In the healthcare industry, for example, they have patients, practitioners, organizations, devices. There's medication administration, medication requests, specimens, medications, locations, you know, just these different types of entities in each of these business areas. I think is a great example of how to break things out when you're normalizing data. And you may want to go further than that or have other things beside that, but I think that this resource is a helpful one. You might as well not have to think about things yourself necessarily, but get kind of an overview for what types of entities might be common in that industry. You know, here we have on manufacturing, the different pieces like a contact, an account, a department, a product classification, vendor capability, that kind of thing. So with that, I'm going to open it up. We've got 20 minutes left in the session, but I'm going to open it up for specific questions if anyone has any. Please feel free to unmute yourself and ask about the specific questions or bring up a topic that you would like to, that you feel like I've missed. Okay, so someone has said normalize.
Just posted in there. Yeah, I just posted this
Yeah.
in the comments. And I do a lot of reporting for the company I work for. And when you take a look at some of the, the performance metrics, we're always looking at how are we doing? And to try to build a table structure that is really flexible so that you don't have to go back in and change any data structures at all, but you have the ability to add almost any kind of measure that you want into tables. And so, and just taking a simple look at the miles per gallon. And typically what you'd see is a single table, I kind of noted at the top, and you'd have like a date, a vehicle, the miles, and the gallons. So let's say I filled up with gas. Today is 4:27. I'm in the Volkswagen. I'd gone 240 miles, and I put in 21 gallons. Okay. So then, of course, you're not going to store the calculated value, but then you can calculate your miles per gallon from that one record. What I've kind of moved to, in our group, is a more flexible system for storing that. And it's kind of a when, a where, a what, and the value. So the when would be, April 27th. The where is like the Volkswagen. What does this number relate to? And it's our Volkswagen. And what is my measure? My measure is miles, and my value is 240. And then I create another record that's April 27th, Volkswagen, and then gallons, and it's 21 gallons. Okay, so as you can see, your what column and your where column, you can put pretty much whatever you want in there. Our where is typically a factory or a production line, and our what is maybe something like quantity produced or hours that the line was occupied, or and it may be something like the my first, or after the miles per gallon. One of the things we track is our safety. Safety is really huge. So in the same table, same exact structure, I can put in my safety stuff. I can say that in March of 2021 at our Chicago factory, the number of accidents was 3, not real numbers. And then March 2021 in Chicago, the number of employee hours was, say, 100,000. But my accident rate, that is the key, the KPI, key performance indicator we look at on a monthly basis, is a number of accidents times like 1,000,000 divided by the employee hours. Now, if somebody wants to come and say, okay, we want to measure, in our production, how much water we consume, I can say, okay, for the same, for this month for Chicago, the tons of production of product, let's say we're, 100 tons. And then another record would have the amount of water consumed during that same period. And let's say that was 20,000 gallons. And then our water rate, which we would calculate, is tons of production per water consumed. Now, in that single table model at the top, where I had miles and gallons as column names, instead of being data values, I would have to create like a separate table for almost all of these. Or for every measure, I would have a column. And in this scenario, I can put in whatever I want. And instead of having a programmer involved was saying, okay, we want to start tracking, some other kind of a indicator. Well, let's just add in the what's, the say a lookup table that says, oh, here is what we're going to track, the one measure, and then here is the other measure, and then here's the calculation. And with, say crosstab queries, the Access SQL language, with Power BI, to get this to look like a single record is easy. It's a simple transform of your data that looks kind of like a crosstab query in a way, but it is very, very easy for, you put the onus back on our report writers to take that data and to kind of transform it into, multiple columns so that in their reports, they can report out the result of those, this divided by this or this minus this, and you can create some really.
I think we lost him. So I like this example. It's not so much an example of normalization, I don't think, as generalization.
Yeah.
Are you back?
Yep,
Or is
I think
that
so.
okay?
Yeah.
Sorry.
No, it was on my
faded out
side.
there.
Yeah, it was
Yeah.
my side, and I heard it go out. But
So
yeah,
go
yeah.
ahead
So
with what you were
yeah,
saying, though. Yeah.
yeah. So it and it's not a lot of work for a report writer. In 5 minutes, I had no knowledge of like Power BI and how to transform the data, and it just becomes a really quite simple method of doing, of doing the reporting. Not that everybody's reporting in Power BI, but a crosstab is also very simple to create a crosstab that, we're going to have the miles per gallon, we're going to group by, the when and the where, and then we end up with columns. So it's transforming, so it's unnormalizing your data using a crosstab or a really, really simple transformation, either in your report or in your transform for like your Power BI presentations and stuff. And of course, we have lookups. I mean, I had the names of my measures like miles and gallons and accidents and employee hours and that, and those are all, dimensional lookup table kind of things that we can add to. So if I want to add another measure to look at, I simply add it to a table. It becomes available.
Well,
And yeah.
And I might encourage you, if you were going to normalize this and still keep it generalized, you might do something like have an event table and have the event ID, the when and the where
Yes.
be part of one table. And
Yep.
then you would also have that event ID along with a, what are we going to call it? A measure table maybe. So
Yep.
you'd have that event ID and then the what and the value. That would be
Yep.
a bit more normalized, and you could,
Sure.
then have, you wouldn't have to necessarily pull in that when and where. So that wouldn't have to be in multiple places. You would just have that ID in there.
Yeah.
And you can, it is very common in reporting to uh, what we're talking about is normalizing today, but
Yep.
there's also such a thing as denormalizing. And reporting tends to be more denormalized, which usually you take tables in something like Microsoft Access and you join them together in something that looks a little bit more meaningful, has less IDs in them, and more just data pieces. And denormalized data used for reporting often does have repetitive data, and that's okay. Your reports should have it. It's just your data storage ideally should not have repeated data. So let's go on to some other questions here. We have one question about this particular example from Charles, and maybe you've already answered this. If so, Charles, maybe let us know. I think what he wants to know is how then do you calculate the miles per gallon when the values are in two different rows? And I think you answered that, but maybe if you could just re-answer that simply.
I would, if I was developing only in Microsoft Access, okay, which most of us are, you would create a really simple crosstab query that would have, your table that has a when, where, what, and the value. And you would, in a crosstab query, you can specify multiple row headings. So your row headings would be the when and the where, okay? So you're going to have, and then your column heading is going to be what, and the value is going to be the value. So it would basically take, let's say, the miles per gallon, and your column headings, you're going to create a column heading for miles and a column heading for gallons. So you're going to have one row, for instance, from those two, and it's going to have April 27th. It's going to have Volkswagen. It's going to have from your column headings, it's going to create a dynamic column called miles and a dynamic column called gallons, and they're going to have the appropriate value underneath them. Because this is for reporting. You're not going to do data entry into this because a crosstab you can't enter data into it. But that's how I would do it. So you'd have the crosstab is our friend, and they can be really, really daunting for beginners, but they can be really, really powerful. And then the same thing, if you bring this over to an Excel pivot table, you do the same thing, where you have your miles and gallons kind of become your column headings there, and then you have the value.
Well, and you can then take those two values and always assume that the first one is your, let me get this right, I'm a half math major and I don't remember. Your first
Numerator?
one is your numerator,
Yeah.
and your second one is your divisor, and then do a calculation. Now that kind of thing only works if all your measures are in that method, and if you have a way of ordering the two, to go in that correct. Otherwise, you're going to get gallons per mile in some cases. So there's probably some tricks to doing this, but
yeah. Crosstabs are a whole nother hour discussion at some point.
Definitely. And I think someone did do one of the Access user groups, maybe the Eastern Time group, did a crosstab presentation about maybe 3 or 4 months ago. If you're interested in more about crosstabs, you might check out our YouTube channel for that. And there's like a list under a playlist under each of the chapters. So the Eastern Time, I believe, is the one who did that one. So we have another question from Giorgio. I'm not sure I understand that question. I don't know if you want to unmute and ask, Giorgio. You ask if Access is part of ISV opportunity flow.
Yes, because you see, you are showing a page from the Microsoft Docs.com that says overview of industry accelerators, and it mentions ISV opportunity flow. So it seems like the Power Platform, Microsoft Power Platform, is part of the ISV opportunity flow, but I don't know if they consider Access being part of the whole equation or not.
Yeah, I would doubt it. Poor Access has a background. But we are going to get later this year the ability to make connectors to Dataverse. And so you could make use directly in Access for some of these created entities, or you could just use them as models right now for Access tables. That's, one of the reason I gave that as an example is, number one, because there's a lot of effort right now on Microsoft's part to design things for use in that community. And it's not only in that community that those concepts could be used. So we might as well take advantage of their efforts. And, even if they're in a slightly different community than our own, and we can use those efforts in our own community as well. Any other questions?
If I can put out a quick question.
Mm-hmm.
So with like if we separate a product item out and the price and we do an invoice, then if we look at that invoice again later, but the price has changed, then the invoice, the historical invoice, is no longer accurate. Suggestions for keeping data that, like a snapshot that you want that
Yeah, so that's kind of up to you. There's two I think methods of thought in that. One method would be not to store the price on the order detail line, but then to have some kind of a hard copy of the completed invoice, and also to store the total value and the net value in the details and in the order header. And if you were going to look at it historically, maybe you wouldn't display the price or something like that, and instead display the PDF that you had of the actual invoice. Another would be to go ahead and include it, but to include a copy, basically copy and paste or use a VLOOKUP to get it there from the price table. But in that case, you would have like a historical price, a price at the time of your order, if that makes sense. And I think that's probably more common. It depends a little bit upon, which way, what your industry is and how you're using data, and do you really go back historically and look at the lines and that kind of thing? Or are the lines used to complete the PDF and then you're really just looking at the PDF historically? So hopefully that answered your question. I do want to point out next month's meeting, we're going to have a guest speaker, Tom van Stiphout, who is a bit of an obsessive compulsive about naming in Access. And he went through a process recently where he had inherited a very poorly named database, which had things like characters that had spaces in them, or field names that had spaces in them, and things like that. And he as developing a tool to go and rename those in that client's database, he decided to take on Northwind, which is not the best design when it comes to character name or field names, etc. So this, the May Access Lunchtime presentation will be about an example of how to go about doing that, and how to clean up a database as far as naming convention goes. So that's obviously a much more advanced topic than today's topic. Today's topic is really for non-Access developers, probably industry people, but we all have uses to refresh our memory in some of these basic concepts as well. And or if you're trying to present to a client or explain why you need to normalize their data, some of these resources from today will hopefully be useful. So thank you all for joining us today, and I look forward to seeing you at a further lunchtime session.
Thanks, Maria. Bye-bye.
Bye.